Hello ENCON managers, greetings from Raghavan, Warpack Group of Companies Pune. I am a specialist from air conditioning refrigeration field with 38 plus years experience. I worked for two American corporate companies in India for a long years, and now I am manufacturing industrial process chillers and hot water heat pumps. I am very happy to be presenting the first of this series on heat pumps, which could be containing about 8 parts, mainly to share all practical aspect information on heat pumps. As ENCON managers, you might have implemented many energy conservation projects. If your manufacturing process involves heating in any of the process, for example, heating up a degreasing or derusting solution, or requiring hot water at 95 degrees for a CIP process, etc., heat pump could be an ideal solution. Heat pump is getting lot of press coverage in the recent past last few years, but right from the invention of air conditioner, the term heat pump was known. Because whenever we say air conditioner, the air conditioner can be reversed. It can be made to cool during summer season and made to provide warmth, heat during winter season. That is how the whole technology has been invented. Many countries on the northern hemisphere, for example Canada, northern part of America, Europe, northern part of China, in all these countries only reversible air conditioners are being sold for so many decades. Though in India only in the recent past, when VRF air conditioners became popular, many of the VRF brands offer reversible air conditioners. So even now in India, many northern cities, they do go for VRF systems which are reversible in nature. So they automatically provide heating during winter season. Now from space heating, coming back to what matters to you, the ENCON managers. So in this 8-part series on heat pumps, we will try to cover as many practical aspects as possible. I hope this will help in triggering some new thoughts and ideas in you, helping you to implement some good energy conservation projects, and which will result in some impact at your workplace. Whenever I visit many industries to check many practical aspects on heat pump implementation, I am surprised to see even today many industries using electrical heater to heat up solutions, even for 45 degrees, 50 degrees centigrade. And furthermore, I also have seen boilers, hot water boilers being used even for producing 55 degrees or 60 degrees hot water solution. So if heat pumps could be applied in the workplace, probably it will be a very good project for your industry in conserving energy. Now let me start explaining what is a heat pump, how it works. Probably that will help to clear some of the concepts in your mind. We all are very familiar with a normal split air conditioner which we have been using at our home or in office. So we have an indoor unit which is producing cold air, and just outside we have an outdoor unit. So we all are familiar with a standard thermodynamic cycle. It works on a reversed Carnot principle. Let me explain the heat pump concept in a very easy to understand way without bringing in all thermodynamic terms and making it a lot more like a classroom session. I don't want to make it a classroom session for you. So whenever in the air conditioner, the unit is on producing cooling on the indoor side, automatically we are throwing up hot air outside because there is a refrigerant which is circulating. It picks the space heat in the form of latent heat of evaporation, and in the outdoor unit it is giving off that heat in addition to whatever heat has been added by the compressor which keeps circulating the refrigerant through the system. So it is giving off the latent heat of condensation to the outside atmospheric air. That is how it heats up the outside air. Now how hot air is being thrown from the outdoor unit? Now being engineers, we may say whatever number you say is not going to be commonly applicable to different brands of air conditioner. I agree. Depending on the airflow volume rate and the heat exchanger design, the outlet air temperature could be slightly varying from brand to brand. But having seen Many lab test results of different brands of air conditioners at standard rating condition, what happens is most of the split ACs throw air at 12 to 15 degrees centigrade higher temperature than the inlet ambient air temperature. For example, if the outside ambient is 35, it is giving off hot air at anywhere from 47 to 50 degrees centigrade. Now, transition to summer time, the outside ambient is 45 degrees centigrade. The leaving air temperature from the outdoor unit could be up to 60 degrees centigrade. Now you may be getting some idea of where I am taking you to. 60 degrees centigrade, most of the degreasing, derusting solutions in your industrial process lines require only that much temperature. So whenever we talk of heat pump, what we do is, it is the same refrigeration system. It produces cooling on one side and heat on the other side. Whenever we are talking about air conditioning, many other chilling equipment in your workplace, you are quite familiar with hydraulic oil cooler, coolant cooler, refrigerated air dryer, water chiller for laser welding machine or induction hardening machine, right? So in all these all require cooling. So here the designer, the manufacturer, we are all focusing on the cooling side, the evaporator side, which produces the cooling in a refrigeration machine. So the refrigeration equipment is same. It uses all the same components: evaporator, compressor, condenser, expansion device, with all refrigeration accessories thrown across in all the high side and low side systems. But our focus is on heating. How do we get the required temperature required for the process? Okay, so we discussed the basic refrigeration equipment remains same, only the focus changes whether we want cooling or heating from the refrigeration equipment. Now I can immediately understand the question that is coming to your mind. Being ENCON guys, you are quite keen to know, can we simultaneously get both and benefit from the machine? Absolutely yes. You can generate cooling on one side, heating on another side, so you can get double benefit by using the same heat pump system. Before I conclude, you may be interested to know what makes heat pumps more efficient. Yes, let us discuss that before we conclude. So whenever we are talking, being mechanical engineers, we always talk about efficiency of any equipment. So what is efficiency? Output upon input. So when it comes to refrigeration system, we don't use the term efficiency. What is the reason? For example, if you take electric heater, you are giving 1 kilowatt electrical energy input to the heater element. At the most, you may be able to get very close to 1 kilowatt. A shade below that we get practically. Let us say 1 kilowatt maximum output you are getting for electric heating. Now, when you give 1 kilowatt input to a refrigeration equipment, depending on what is the envelope within which we are working, it could be the efficiency could be 200 or 300% or 400%. Now, being mechanical engineers, we know efficiency cannot be more than 100%. So in refrigeration, which works on a reversed Carnot principle, which moves heat from a low temperature region to a higher temperature region by employing outside work, that is in the form of using compressor. So we are shifting the heat from a low temperature zone, which is the evaporator, to a, which also we call as a source. We are moving it to the condenser, the high temperature side, which we refer in heat pump terminology as the sink. So we are moving heat from source to sink using a additional external element, which is nothing but the compressor. So because this works on a reversed Carnot principle, the efficiency number, output upon input. What is output? If you are talking about cooling side, the chilling units, then the output is nothing but cooling capacity, watts in thermal terms, because it can be expressed in kilocalorie or in watts. And if it is heat pump, the output is nothing but the kilocalorie or watt thermal generated from the condenser. So that upon the input. Input is the electrical energy we are spending. Which all components take electrical energy in a heat pump? It is the compressor, the fans that we may be using on the evaporator side, or a pump in case you are using water as a source. And on the condenser side, we will be using a pump because we want to heat up the water or a solution. So the pump electrical energy also is included. So whatever energy consuming devices components are used in a heat pump, we total them up, sum them up, and that becomes the part of the denominator. So the output upon input for a refrigeration system, a heat pump, is always high, higher than unity. This is the reason we use a term called COP, coefficient of performance. We don't call it efficiency. So a heat pump COP could be 2 or 3 or 4. You may ask why it changes, how it changes. We are going to see in the coming parts very shortly. So before we conclude, you may want to see a quick proof of is it really this high. You all may be familiar with the star label that we see on split air conditioners, right? It is from BE, Bureau of Energy Efficiency. You will be seeing a term, a number at the center of the label, 2.9, 3.1, something like that. What is that? It is the COP, 2.9 or 3.1 watts per watt. Thermal watts, the cooling delivered, upon the energy consumption watts. Okay, so the number will be always high, 2.9, 3.1. So this is how we say, using heat pumps, you can conserve a lot more energy than whatever you are currently consuming using a electric heating element or by deploying high pressure boilers, etc. So heat pump makes a lot of sense. With all this information, I am sure you will be having many more questions. My only request to you is, if you want to learn more, get more practical application aspects of how to deploy a heat pump in your workplace, please subscribe to this channel. It will encourage me to deliberate more on the practical aspects of implementing heat pump in an industrial scenario. And I also request you to share this video with all your friends who are also ENCON managers, or if you are a member in any of the groups which are working on energy conservation, sharing a lot of ideas on energy conservation, do share this video with them. It might be of help to them also. So thank you very much. Within a fortnight, we will connect again and keep discussing a lot more practical aspects of deploying heat pumps in an industrial environment. Thank you so much.